Hello friends, so today we will solve some numericals related to NEET JEE based on error analysis. So in the previous 3-4 lectures we have learned basic fundamentals related to units and measurement and error analysis, types of error, causes of error, okay, error propagation, okay, and many relations we have learned regarding the error analysis. Today we will solve some numericals based on this topic. Is it okay? So you note down everything, okay? If you have any doubt you can write in comment box, any suggestions, and most important thing, if you are not subscribed to my channel, you have to subscribe it, okay, and share the link of this video to your friends so that they will also take the benefit. This is the free learning, okay, and I hope you are taking benefit of this free lectures, okay. So let us read this numerical. What is given? The length of a rod is measured as 31.52 centimeter. Graduations on the scale are up to what? That is the question, okay. Some options are given: 1 millimeter, 0.01 millimeter, third one is 0.1 millimeter, and fourth one is 0.02 centimeter, okay. So first of all I will make you understand some important things so that we can solve this numerical. Now look, suppose this is one rod, okay, this is one rod and I want to measure length of this, okay. So this is up to some length, okay, and there is a scale. We will put a scale here. This is our scale, okay, and we will compare this graduation. Graduations means what? Scale on that, which is engraved on that, okay, 1 centimeter, 2 centimeter, millimeter, whatever it may be, inches, whatever it may be. Suppose this length is something, let us say this is 31, 32, 33, okay, like this, 34, 30, like this. So this is a scale, okay, from 0 to 30 and onwards, and this rod is kept at 0, 0, okay. Here this is 0 reading, okay, and this is your rod up to this, this is your rod. It is continuous rod, okay. This break I have shown because in between readings I don't have space, that's why, okay. So 0 to, from this point to this point there is a complete rod, and this reading is from 0 to on this side, okay. So here I want to measure it by using this scale. Then I can measure, this is 31 and this marking is 32. Graduations are like this: 30, 31, 32 centimeters, in centimeter. This is a centimeter scale, let us assume, okay. In between there is no marking, so how much I can measure? I can measure 31 centimeter. This is 31 centimeter. I can observe that this length is more than 31 little bit, but I cannot measure because there is no marking, there is no graduation, there is no scale on that to measure that small length. So I will say it is 31 centimeter, okay. If it is more than that, if it is near to 32, I will say it is 32. If it is near to 31, I will say 31. Or suppose this is like this, it is little bit like this, okay, and this is 32. So I will say it is 32 centimeter, but I cannot say it is 31 point something. So by using this type of scale, by using this type of graduations, I cannot measure this 31.52. Reading is 31.52 centimeter, but I cannot measure using this. So smallest graduation on this is what? 1 centimeter. Sorry, 1 centimeter. Yes. Minimum I can measure is 1 centimeter only. If it is 0.5 centimeter length, this is a rod of 0.5 centimeter or 5 millimeter, then this rod I cannot measure here. By using this scale I cannot measure length of this rod. Or 1.5, 1.6 I cannot measure. So list count of this is list count. Every instrument have its list count, means minimum how much it can measure. Minimum how can it measure. Okay, and minimum error done by that instrument will be the list count of that. Okay, so it is what? List count is 1 centimeter. So there is a error. Okay, but that error is what? Less than 1 centimeter. Okay. Now what I will do? I will do some changes in this. So I will change the graduations. I will mark here. I will divide this 1 centimeter everywhere in 10 parts. Okay, 1 millimeter, 1 millimeter, 1 millimeter I will take. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like this. Assume there are 10 divisions. Okay. So now if there are 10 divisions, I can measure this length. So I will try to match this. Okay. So let us say, should I draw the big? Okay. So I will zoom it, this part I will zoom. So this is the end of the rod. Okay, and this is the scale. Okay. So on this side, let us say 5, 6, 4, 3, 2, 1. Okay, and this is what? 31. 6, 7, 8, 9, and this is what? 32. Now this part, okay, this portion I have zoomed here. Okay, so this is divided everywhere from 0 to that dent. Now this is a millimeter scale, we can say. Okay, so 30, smallest division is 1 millimeter. Previous case, smallest division was 1 centimeter. Now smallest division is 1 millimeter. Smallest division is 1 millimeter. So 1 millimeter length I can measure minimum. Below that I cannot measure. Or 1.1 I can measure, but 1.12 I cannot measure. Let us observe this. So this I can say 31.5 or 6. So one can measure 31.5, another person can measure 31.6 here by using this scale. One person can measure 31.5, another person can measure 31.6. Both of them understood that the end of this rod is in between 5 and 6, but we cannot measure because there are no marking, no graduations. Smallest graduation is 1 millimeter. See, so here in this case, for this scale, list count is what? 1 millimeter. In the previous case it was 1 centimeter. List count was 1 centimeter, means it was 10 millimeter. List count. Now here we have divided this 10 millimeter or 1 centimeter in 10 part. So minimum length we can measure is 1 millimeter. That list count of this is 1 millimeter. So error will be that much. Now previous case error was in between 1 centimeter. Maximum error was 1 centimeter and it was less than that. We have got last time we have got 32. So error was this much. 32 minus this, that was the error, less than 1 centimeter. Now here we are measuring this or this. So error can be 0. So if this is the error, this is the reading 31.52 minus 31.5. So error is what? 0.02. Okay, 0.02. Yes or no? This much is the error, right? So it is less than 1 millimeter. Maximum error can happen is 1 millimeter or less than that in this case, and maximum smallest value we can measure is 1 millimeter using this scale. Okay, so using this scale also we cannot measure this length 31.52. Okay, so again we have to divide this small length in 10 parts. So again divide this in 10 parts. So that at that time what will happen? This 5 and 6. Okay, so this 5 and 6. Again 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so in between here this is the end now. This is the end of this rod. Okay, so somewhere here on this side it was somewhere on this side it was 31, on this side somewhere 32, so 31.52 we can measure. Okay, so 31.5 already up to this, after that 1 2 1 2. Okay, so 31.52 52 we can measure now in this case. But now what is the smallest value? 1 centimeter. Okay, 1 centimeter means 10 millimeter divided by 10. Okay, so least count so was 1 millimeter. Now 1 millimeter is divided by 10 divisions. Okay, 10 in 10 parts. So this will be 0.1 millimeter. So smallest graduation needed on the scale is 0.1 millimeter, so that we can measure this length 31.52. Otherwise not possible. If this is the scale, we can measure up to 31.5 only, 31.5 or 31.6 up to 1 decimal place. In this case, only we can measure 31 centimeter or 32 centimeter. In decimal, we cannot measure. That is the meaning, least count, smallest reading, graduation, everything. Got it? Now what is the answer? The length of rod is measured as 31.52 centimeter. Graduation on the scale are up to, it should be up to what? 0.1 millimeter. Then and only then we can measure. So there must be 0.1 millimeter, smallest division should be there, so that we have got this length. Okay, so this is the answer. Got it? Got it or not? So note down this very important concept. Okay, so I will erase this and we will solve another numerical. Okay. So now look, the two resistors R1 3 plus or minus 0.3 ohm, R2 5 plus or minus 0.1 are connected in parallel. The equivalent resistance is 4 options: 1.9 plus or minus 0.1, 1.9 plus or minus 0.2, 1.9 plus or minus 0.3 and 1.9 plus or minus 0.4. Okay. So how to solve? Now first of all, in parallel arrangement, okay, so resistors in parallel, resistors in series you might have learned in 10th standard. Okay. So this is R1, suppose this is R2. So here 1 upon R, equivalent resistance of these two is 1 upon R divided by 1 upon R1 plus 1 upon R2. This is the formula. If you have not learned, you will learn in 12th standard, in current electricity chapter. Okay, chapter number 3, in that we will learn. So time being I will give the formula, don't worry about that. So 1 upon R is equal to 1 upon R1 plus 1 upon R2. So if you will simplify this, we can write this 1 upon R is equal to this R2 plus R1 divided by R1 into R2. So more, if you simplify 1 upon R, reciprocal of this will be reciprocal of this on this side, R1 by R2 divided by R1 plus R2. Okay, so this formula we will use. R is the equivalent resistance of these two combined. Now this is the formula to calculate R. So let us calculate R first. So R will be what? R will be R1. What is R1? R1 is 5. R1 is 5 into R2. R2, sorry, we will take 3. R1 is 3, no? 3. Okay, so 3 into R2 is 5. 5 divided by R1 is 3 plus R2 is what? R2 is 5. So this will be what? 5 3s are 15 and this will be 8. Okay, 15 by 8 is a equivalent resistance, right? Now Now error in this combination, okay, is written as delta R, error in resistance will be equivalent resistance square is equal to error in R1 divided by R1 square plus error in R2 divided by R2 square. Okay, this is not a relative error. Relative error is what? Delta R by R is equal to delta R1 by R1 plus delta R2 by R2. This is the equivalent error for what? If R is equal to R1 into R2. If R is equal to R1 into R2. But R is not simply R1 into R2. It is R1 into R2 divided by R1 plus R2 combined. Okay. So in that case we have to use this formula. Okay. So we will not go into the proof of this. Directly you use it. Remember this. In many numericals this formula they will give. In the NCERT book also, in the statement itself they have given this formula. But if not given, then also no problem, you remember this formula. Okay, this is not the relative error. Basic formula for multiplication is what? Addition of relative errors. But here square is there. So in this type of numericals, okay, when such a situation comes, you can write like this. Based on using this, we can calculate this error. Okay, let us try. So delta R by R is equal to R square is equal to delta R1. Delta R1 is a error in this 0.3. Okay, 0.3 divided by R1 is how much? R1 is 3 square plus delta R2 is how much? 0.1 divided by R2 is how much? 5 square. Okay. Now delta R by R square is equal to what? This we can solve. 0.3 into 5 square plus 0.1 into 3 square divided by 3 into 5 bracket square. Yes or no? Or you can write separately also, no problem. 3 square into 5 square. Yes or no? But this R2 is what? R2 is 15 by 3. R2 is 15 by 3. So this we can write here. 15 by 8. 15 by 8 bracket square. Okay. So you take this on this side. So delta R is equal to this. How to solve this? So let us calculate this. 0.3 into what? 25 plus 0.1 into what? 9 divided by 3 square 9 into 25 into this will be what? This complete value in the denominator, this will go in the numerator. Okay. So delta R is equal to what? So this will be what? 25 into 3, 75. So 7.5 plus 9. So 0.9. Yes or no? Yes or no? Divided by this 9 into 25 into this 15 can be 15 square divided by 8 square. So you can simplify this. So this we can solve, and finally what answer you can get? To make it fast I will use calculator. Actually calculators are not allowed. Okay. So So this value is delta r is equal to 0.13125. Okay. So approximately we will take this as a 0.1. 0.13 no. So if this is less than 5, we can take this value as it is. So that is approximately 0.1 is the error, Okay. Now what is asked? The equivalent resistance we have to calculate. So equivalent resistance will be what? Equivalent resistance is what? This R, true value of the equivalent resistance, plus error in that, plus or minus error in that 0.1, or this is what? Delta R. So this will be what? R equivalent is what? R is how much? This R we have calculated. So 15 by 8. So 15 by 8 how much? 15 by 8 is 1 point. This is what? 1.875. Approximately this is 1.9 ohm. Okay, 1.9 ohm. So this will be 1.9 plus or minus this 0.1. So this is the answer. So 1.9 plus or minus 0.9. Why I have taken 1.9 instead of this 1.8? Because in the option there is 1.9, 1.9, 1.9, 1.9 everywhere. That is why I have approximated it to 1.9. Okay. And here also up to 1 decimal place values are given, 0.1, 0.2, 0.3, 0.4. If they have given 0.13 something or 1.2, 1.3 something, so up to 2 decimal place I have taken that value, but in the option only up to 1 decimal place. So that is why this I have approximated to only 1 decimal place, that is 0.1. So this is the answer. Okay. So in this way we can solve these numericals. Here proof of this is we have not taken. Okay, you remember this formula. This is not the relative error, delta r by r square, not relative error. This is a combined effect, okay, with error of this formula. Clear? Okay, so note down this, pause it and note down this. So now look, example number 3. A body travels uniformly at a distance of 20 plus or minus 0.2 meter in time 4 plus or minus 0.04 second. The velocity of the body is, some options are given. Okay. So how to calculate? So what is velocity? Velocity is what? Rate of change of displacement is a velocity, means distance traveled, distance covered in time is called velocity. Okay. So this is the division of s by t. So this is the division. So this velocity we will calculate first. So what is the displacement? S is equal to what? S is equal to 20 plus or minus 0.2 meter means what? Means what? 20 is the true value of displacement and this is the error in the measurement. 0.2 meter is the error in the measurement, and time is what? 4 second. 4 second is the true value and 0.0 second is the error in this measurement. So if you want to calculate this velocity is equal to what? 20 divided by 4. So this will be 5 meter per second. Okay. So this is a true value of velocity. Now we have to find out the error. So everywhere 5 is there. So we cannot decide the answer. So we have to calculate error. So error will be what? Now this is the division. So error we cannot calculate directly. Yes or no? We cannot calculate directly error, but we can calculate relative error. So first write down the expression for relative error. From that you will get error. So expression for this is what? Let us say dv is the error in measurement of velocity. dv by true value of v is a relative error. Okay, this relative error or fractional error in velocity can be written as a addition of relative error in displacement. Okay, here simply I will write, yes, because you should not confuse in between time and this delta error and this small displacement. Okay, so error in displacement divided by total displacement plus error in time, okay, divided by actual time. So this is the relative error in displacement, relative error in time, this we have to add because there is a division. In multiplication and in division, relative error we have to add. Okay, so dV by V is how much? We have calculated 5 is equal to delta S, error in displacement is 0.2 divided by S, only positive value we have to take, plus or minus is the error, but here in the relative error what is this? This is the mean absolute error, means positive value we have to take. Okay, so 0.2 by S, S is how much? 20, yes or no? 20 na? Delta T, error in time is 0.04 divided by what is time? 4. Okay, so let us solve this. This will be what? 0.2 divided by 20, so this will be 0.01 plus 0.04 divided by 4 is equal to what? 0.01, correct na? Yes, correct. 0.2 divided by 20 is how much? So this will become what? 0.02. Okay, so delta V by 5. Now this 5 I will take on this side. So delta V, error in this will be into 5. Okay, so this will be ultimately 5 into 2. 1, 2. So 0.1. Okay, 0.1 is the error. 0.1 meter per second is the error. 0.1 meter per second is the error in this measurement. So what is the final answer? V final is equal to what? Velocity plus or minus delta V. We measured is what? Or we calculated by using formula is what? V is 5 plus or minus 0.1. So this is the option. So where is the option? Yes, meter per second or meter per. Okay, so this is the answer. Right? So in this way we have to solve the numericals. So we will stop here. 3 numericals we have solved. In future again more numericals based on this we will solve, but first we will complete the all theoretical concepts. Next in next lecture we will start dimensional analysis. What is the dimension? What is dimensional formula? Okay, what is the importance of that? Principle of homogeneity. Okay, what is that? What is the application of dimensional analysis? Okay, and some examples related to NEET and JEE. So after this 2-3 videos I will record on dimensional analysis. Okay, so time being you study well. Okay, you note down everything, pause the video and note down everything. If you have not understood, you rewind it and you try to solve more number of numericals. If you have not understood anything, you can write in comment box so that I will prepare a video on that and so that we can learn. Okay, if you have any suggestions, then also you can write in comment box. Okay, subscribe my channel if you are not subscribed. Forward the link to your friends. Help me in my journey. Okay, best luck.